Hello students. So students, in the previous class in this chapter, that is chemical reaction and equation, we were talking about the steps which is involved in a chemical equation. If we talk about the step itself, before that students, we had discussed about a chemical equation. And we have seen that a chemical equation is a process of representation, or it's a schematic representation of a chemical reaction with the help of a formula or symbols involved. And here the reactant are written at the left hand side and the product is written at the right hand side. And the chemical equation is also divided into two, that is the balanced chemical equation and unbalanced chemical equation. Question is that why there is a need of balancing a chemical equation? So the reason is that since we have to fulfill the law of conservation of mass, and due to which we used to balance the LHS side, that is the reactant side, and the product. Which one? It means the number of atoms present at the left hand side must be equal to the number of atoms of each element present at the right hand side. Or we can say that number of atoms of each element at the reactant will be equals to that of the, or must be equals to that of the number of atoms of the elements present at the product side. Now, this is the reason that why we are balancing a chemical reaction, that is in order to maintain, in order to fulfill the law of conservation of mass. So if both the side number of atoms are equal, so they are following the law of conservation of mass and they are said to be the balanced chemical equation. And if it is not like that, then it will be an unbalanced chemical equation. Now, how we can balance a chemical equation? So there are some of the steps which is involved in balancing a chemical reaction. You see, we had discussed the first step in which we will write the skeletal equation by using the formula or the symbols which is involved, which is required in that of a chemical reaction. Then the second thing, that we will choose the particular element which is having the maximum number of atoms. Okay, so we will select that particular element and then we will try to balance it with a suitable number of atom to the other side. While choosing the atom or while choosing the element which is having the maximum number of atom, we will never gonna consider that it is from which side, that is it can be either from that of the reactant or that of the product side. Then the third thing that we will going to see here, that after that we will going to choose one by one atom and try to balance it. Now, while balancing, by taking one by one, we can do if it is necessary, what we will do, we will multiply also the whole equation by 2. Okay, so multiply the whole equation with the suitable number if it is required. Then students, after balancing, when you have balanced or you are thinking that okay, now the chemical equation is balanced, how will you confirm yourself? You will confirm by checking each atom at both the sides, that whether the number of atoms present at the left hand side of each element and the number of atoms at the right hand side, that is at the product side, is equal or not. If each of the elements at both the sides are equal, then we will say that the equation is now balanced. So this is the steps which is involved in a chemical equation. Now here, one more thing I really want to add that what happened in case of a ionic reaction, if the reaction is the ionic one. Checking one by one. In case of a ionic equation, what is the thing that we have to see is, in case of ionic equation, the charge on either side if we talk about the either side, it means we are talking about the left side and the right side. It means at the reactant side and at the product side. Okay, so charge on the either side of the equation should also be balanced. Now, why I am writing this step, students, so that you will get an idea that how we will be able to balance the chemical equation. So, I hope you have understood the step. Now, we will able to understand with the help of an example. So, let us see that how can we balance a chemical equation. So see here, let us write an equation here. Like suppose if iron is there and this iron react with that of the water. Due to which there is a formation of Fe3O4 and H2 is liberated. Okay. So if we want to balance this particular equation, now the question is that why, let us see that is a balanced or an unbalanced chemical equation. So you can see here iron is 1 and here iron is 3. Here oxygen is 1, here oxygen is 4. So it means at both the sides the number of atoms of each element is not equal. So it is an unbalanced chemical equation. So this equation we are going to balance it. So, first of all, students, the thing that we will going to check it is, we will see the particular formula which is having the maximum number of atoms. So, first of all, we will select this Fe3O4. Okay, so we can write it here. We will select the compound which is having the maximum number. We will select the compound which is having maximum number of atoms. So we are going to select the first one, that is Fe3O4. Now here there are two elements involved in this particular compound, that is iron and oxygen. So what we will do, we will going to balance the iron and then we will going to balance the oxygen, students. So you can see here, or you can do anything, means you can take the oxygen itself and oxygen is 4. So you can do that, we can simply balance oxygen first and then we will move to the iron. So you can see here at the product side, at the right hand side, the number of oxygen is 4 and here the number of oxygen is 1 only. So what we can do, so we can write it here. So here we can write it 4. Okay. So now the oxygen is 4 here. Here also oxygen is 4. So oxygen is balanced. Now moving on and see that what about the iron. So iron is 3 here. So what we will do? We will write here 3. Now iron is also balanced. So iron is 3, oxygen is 4 at both the sides. Now last is about that of the hydrogen. So you see hydrogen, here hydrogen is 2 and here hydrogen is 4. Now this 4 is for a whole compound. So this 2 will multiply with this hydrogen 4, this 4 which is multiplied with the whole compound. Now this 4 into 2 will be equals to 8. So how many hydrogen is there here, students? That is 8. Okay. So it will be 8. So with suitable number that will be going to multiply at the hydrogen so that it will become a 8. So we will write here 4. So if it is a 4H2, so it will be actually a 4 into 8, that is 8 hydrogen atoms. So now we are saying that this equation is balanced. How we will check it that this equation is balanced or not? So first of all, we will see that number of iron at this particular side. So here iron is 3. Here also at this side iron is also 3. At this particular side, here the hydrogen is 4 into 2, that is 8. At the product side, 4 into 2, that is also equals to 8. And oxygen is 4 here and here also oxygen is 4. So you can see that each element, number of atoms at each element at both the sides are equal. Now moving on and let us see the next chemical equation. So now let us see the second example, and that is ammonia formation, that is N2 plus H2. This will give NH3. So this is the chemical equation which is given and we have to balance it. So first of all you can see that here the number of hydrogen as this side is 2 and here the number of hydrogen is 3. This side the number of nitrogen is 2 and this side the number of nitrogen is 1 only. So you can see that if suppose we will consider that of the nitrogen. So nitrogen is 2 here and here nitrogen is 1. So what we will do, we will balance this nitrogen by multiplying it with 2. Now you can see here, this time this nitrogen will become 2 and this side also the nitrogen is 2. So nitrogen is balanced. Hydrogen now, again it was already unbalanced, now again its value changes. This time, this hydrogen, it was having the 3 atoms, will multiply with this 2, it will become 6. So 6 hydrogen atoms are here, but this time here it is still 2 hydrogen atoms. So we will multiply this particular hydrogen with a suitable number so that we will get a 6. So you know that if you multiply it with 3, then we will get 6. So we will write here 3. Okay, so 3 into 2 will be 6H and the 6H there. Now you can see here, student, at both the sides the number of nitrogen and hydrogen are equal. Another example, students, you see the example of respiration. So you see, basically what happens in a process of a respiration, there is an evolution of a heat. Energy is released. You know that this energy is stored in our mitochondria in the form of a ATP, which is used for the time to time, you can say. And basically what happens in the respiration process, which occur in the plants as well as in the animals, that glucose, which is the food, this glucose is oxidized. Breakdown of the glucose occur. And how this oxidation process occur? With the help of the oxygen. And you know that oxygen and food, these two are necessary since it provide energy. And how it provide energy? Due to the process of the respiration itself. So you can see that first of all we will take the food, that is glucose, C6H12O6. This is the formula of the glucose. When this react with the oxygen, that is 6O2. Sorry. Let me write it. O2. O2. Then there is a formation of a carbon dioxide, water, plus heat is also released, students, in the form of a ATP. Okay. Now, what we have to do, we have to balance it. Because you can see here the number of carbon is different, 6 here, here 1 only. The number of hydrogen is also different, there 2 only, here 12. And number of oxygen is 6 plus 2, that is 8. And here 2 plus 1, that is 3. So what we have to do, we have to balance this chemical equation. You can see that here the hydrogen is 12 in number. And this side, the hydrogen is 2. So at first we will going to balance the hydrogen. So hydrogen at this is 12 and here hydrogen is 2. Now, which suitable number that we should use so that this hydrogen will also become 12. So if we will multiply this with 6, so you know that 6 into 2 is equals to 12. So what we can write here? 6. Now you can see 6 into 2 that is equals to 12 and 12 hydrogen is already there. So at both the sides the number of hydrogen is balanced. Now, so hydrogen is balanced. Now let us see about the carbon itself. At this side the number of carbon is 6 and at this side the number of carbon is 1. Now by which number we should multiply this carbon 1 so that it will become 6. So 1 into 6 will be equals to 6. So we will write here 6. So now carbon is also balanced. This side also carbon is 6 and that side also carbon is 6. Now moving on, and we will see the number of oxygen atom at the both sides. So here oxygen is 6 and this one also, this 6 plus 2, that is equals to 8. At this side oxygen is 6 into 2, that is 12 plus 6. That will be equals to 18. Okay, so at this side it is, this is 8. Now you see students, how much oxygen is necessary here? That is 10. Okay, so 10 more oxygen is necessary so that the oxygen will be balanced at both the sides. So you see here at two sides, means at the reactant, both of the reactant consisting of the oxygen. So if we add this 10 to any of this reactant side of the oxygen, we will get the value, that is 18. Now which one will be easier to do that? You see that this oxygen is attached with hydrogen and carbon also. So if anything will be added or if anything will be multiplied with this particular compound, this particular formula, it will going to change the number of a carbon and hydrogen of the reactant also, of the both of the sides also, of the product also. So instead of doing that, what we can do, we will add this 10 to this particular oxygen. Now how many oxygen are present at this particular oxygen gas? So that is 2. So if we add the 10 also, it will become 12. So if this oxygen will gives us a 12 number of atom, then both sides of the oxygen will be balanced. So which suitable number that we should use here? So we will use the 6. So 6 into 2 is 12. So now we can say this will be 12 plus 6 and that will be equals to 80. Now you can check also that whether each of the element at both the side and the number of atoms attached with it is equal or not. Now let us see another equation. This is very important, student. You all should know the chemical equations. Moving on and see another equation, and that is C6H6 plus O2. This will give CO2 plus H2. Okay, C6H6 plus O2, that will give CO2 plus H2. Now, first of all, we will select a compound which is having the maximum number of atoms. Okay, so first of all, you see that a hydrogen here, carbon is 6, hydrogen is 6. Carbon is 1 here, oxygen is 2. Hydrogen is 2 here and oxygen overall is 3. So you can see here that hydrogen is 6 and then hydrogen is 2. Carbon is 6 and carbon is 1. So carbon and hydrogen is 6 only, and here carbon and hydrogen is 1 and 2. So you can take any of the one that is either carbon or that of the hydrogen itself. So first of all, what we will do, students, we will take the carbon itself. So carbon is 6 and here carbon is 1. So if we multiply the carbon at this side into 6, so we will get the carbon at both the sides equal. So we will write here 6. The carbon at this side will be 6, at this side also it is 6. So carbon is balanced. Now let us see hydrogen. So hydrogen at this side is 6 and hydrogen at this side is 2. So we want to balance it. So by which suitable number that we will multiply at this side so that we get the value that is 6. So you know that if you multiply it with 3, we will get the value that is 6. So 2 into 3 will be equals to 6. Here hydrogen is 6 only. So what we will do? We will write here 3. So you can see that carbon and hydrogen at both the sides are equal. Now what about the oxygen? So oxygen is here 2. And at this side oxygen is 6 into 2, that is 12 plus this is 3, this will be equals to 15. So oxygen as this side is 15 and this side it is 2 only. So if we will want that this oxygen and this oxygen must be equal to each other. So if at this side the oxygen is 15 by 2, already it is 2. So if we will multiply it with 2, then it will become 15. Okay, so what I want to say to you, student, that by which suitable number we should multiply this particular oxygen so that we get the value that is 15. So if we will multiply this oxygen by 15 by 2, so we will get the value that is equals to 15 itself. But you know that we cannot do the fraction one. But we can do one thing, that is we will multiply this particular oxygen by 15 and we will also multiply this whole equation by 2. Okay, so that will be much easier for us to get the value. You can see. Multiplying this whole equation by 2. Now consider here itself that it is a kind of a 2 only. You just It's a kind of a hypothetical so that you can understand the equation very well. Okay, now when you multiply this whole equation by 2, so it will become 2C6H6 plus 15O2, because we have considered that 15 is already there. So 15 by 2 into 2, this will become to 15 only. So there will be no change in the 15. And this will be 6 into 2, that is 12 plus 3 into 2, that is 6H2. So you can see here that except this one, if we will multiply this whole equation by 2, we will get the value. Okay, so we can write it, we can balance the equation or balance the oxygen by multiplying O2 on LHS by 15 by 2 and multiplying the whole equation by 2. Okay, so by considering the oxygen as 15 by 2 and multiplying this whole equation by 2, we will get the correct value. Okay, now moving on and check out another equation. And the equation is when the hydrogen sulfide H2S combined with O2, then SO2 plus H2O will be formed. Now let us see here that what are the things which is balanced or not. If we look at the hydrogen, so hydrogen at this side is 2. And hydrogen at this side is also 2. If we talk about the sulfur, so sulfur at this side is 1 and sulfur at this side is also 1. So that is also balanced. Oxygen at this side is 2 and oxygen at this side is 3. So the thing which is not balanced in this chemical equation is the oxygen. Now again here students, like we have done in the previous equation, just now that equation that we had done, we have seen that if we want to make it equals to the other one, we will divide it with the same number and multiply the whole equation with the denominator, right? So if we want that this oxygen will also become 3, so what we can do, we will multiply this with 3 by 2 and multiplying the whole equation by 2 itself. Okay, so we can write it that in order to balance it, in order to balance the equation, we will multiply O2 by 3 by 2 and multiply the whole equation by 2. Now you can see here student, if we will multiply this whole equation by 2 and consider that this is a 3 by 2. It's a hypothetical. Again, I am telling you. O2. Then it will become, that will be also 2. Now, it will be, first of all, we will going to multiply it with 3 by 2. So, it is SO2 plus S2O. Now, what we have to do, we have to multiply the 2, the whole equation by 2. So, if we will multiply the whole equation by 2, it will become 2 H2S. This will also be multiplied. So, it will become 2 into 3 by 2. So, this 2 will be cancelled. So, now it will become 3O2 only. So, we can write it here. 3O2 plus, that will be equals to 2SO2 and 2H2. Now, if you want to check, you will find that the number of atoms at both the side of the element is equal. Hydrogen is 4 here. Hydrogen is also 4. Sulfur is 2 here. Sulfur is also 2. Oxygen 3 into 2, that is 6. Here 2 into 2, 4 plus this 2, that is equals to 2, 6. So, at both the equation, the number of oxygen is 6.